For many years, fuel cells have been touted as the future of automotive transportation. In fact, some proponents suggest that they're the first wave of a hydrogen economy, but others aren't so sure. In this EVU mini course, we'll examine the fuel cell vehicle, how it can be considered part of the EV landscape, and how fuel cell vehicles compare to BEVs. A fuel cell is like a battery. And by the way, if you're unfamiliar with EV battery concepts, you might want to view our course EV 210 before continuing with this presentation. But back to fuel cells. Fuel cells have the same components: an electrolyte, electrodes, and a form of separator that can be found in an EV battery. In most automotive applications, the polymer exchange membrane fuel cell is used. Let's explore the basic elements for the PEMFC. Hydrogen is forced through a platinum catalyst under pressure. The catalyst splits the hydrogen into 2 ions and 2 electrons. The flow of electrons, that is electricity, can be used to power the EV motor directly, or it can be used to charge a battery that provides power to the motor. The hydrogen combines with oxygen to form water, which exits as steam. Each polymer exchange membrane fuel cell is combined into a stack to provide sufficient voltage to power the EV. But where does the hydrogen that feeds the fuel cell come from? One method is hydrogen electrolysis. Current is passed through water and hydrogen and oxygen are separated out. The problem is that this approach is very energy inefficient. Another approach is called natural gas reforming. Steam is superheated to about 800 degrees Celsius. It's then combined with methane. The chemical reaction that results produces hydrogen, along with carbon monoxide and CO2. Still, other methods have been investigated, including biological production, photoelectrochemical water splitting, solar thermal, and photoelectrocatalytic methods, but these have not been widely implemented to date. So, once the hydrogen is produced, how does it get from the production facility into a fuel cell vehicle? First, it's liquefied and transported by tanker truck to a hydrogen refueling station. These specialized refueling stations are currently very rare, with fewer than 50 in the entire United States. At the station, liquid hydrogen is stored at minus 250 degrees C. As it's needed, liquid hydrogen is converted to gas, pressurized, and pumped into an onboard fuel tank. The good news is that filling the tank takes 3 to 5 minutes. Unlike a PHEV, the fuel cell electric vehicle, an FCEV, does not charge its battery from the grid. As we just discussed, it makes use of a fuel cell, shown schematically in red, that initiates an electrochemical reaction with fuel, in this case hydrogen, to create electricity that charges the battery. The fuel cell can also provide direct power for an electric motor. An FCEV has 1 or more onboard fuel tanks, shown in orange, that contain pressurized hydrogen. As we just noted, the vehicle must be refueled at a hydrogen fueling station, an infrastructure element that is quite rare today. In the next part of this EVU mini course, we compare FCEVs and BEVs.